All right, so if you look on page 256, there's a lot of theorems and stuff there. You don't necessarily have to put them on your theorem postulate sheet. We're not worried about them really as theorems. I just want you to make sure you know these characteristics of a parallelogram. So the first one is that consecutive angles of a parallelogram are supplementary. So what does supplementary mean? Right, they add up to 180. So that means any two consecutive angles in the parallelogram. So the consecutive angles, let me label my, so let's say we have A, B, C, and D. So consecutive angles would be like A and B, or B and C, or C and D, or D and A, right? So any of those pairs are going to add up to 180.
Wait, what?
So like the measure of angle A plus the measure of angle B would equal 180.
Okay.
Right, and then B plus C would equal 180. Right, and C plus D would equal 180. D plus A would equal 180.
Oh.
Right. And then the other thing we know about angles of a parallelogram is that the opposite angles are congruent. So that means that like angle A is going to be congruent to angle C, and angle B is going to be congruent to angle D. So opposite angles in a parallelogram. Right, so another theorem we have is that opposite sides of a parallelogram are always congruent. Right, so I'm going to label this again. So that means that like this side is congruent to this side, and this side is congruent to that side. So also when you have a parallelogram, oh, that's a really bad one. We're going to have to try that again. I wonder if I can do this, but then make it like slanty. Nope. So when we have a parallelogram, we can draw what are called the diagonals. So basically we're just going to draw like a line from like the opposite and connect the opposite angles. So like this would be a diagonal, and then we have this diagonal. Right, so in a parallelogram, we have a theorem that says the diagonals of a parallelogram are going to bisect each other. So who remembers what bisect means? Right, so it splits it in half, right? It separates it into two congruent pieces. So if the diagonals bisect each other, that means the blue line where it crosses the red one is going to split that red line into two like equal parts. So those two pieces there would be the same length. And then the red line is going to split the blue one into two even pieces as well. Does that make sense? Okay. So those lines split each other in half. They are, yeah. It's really throwing me off.